Greetings, respected Jignesh sir. Here I stand before today to present a captivating and informative PowerPoint presentation on our project submission for the subject EE160, titled Power Generation and Power Plants, in which we will be explaining about the basic types of power generation power plants in detail. So let's initiate the presentation with the same. First of all, introducing to the power generation system, so we can easily say that in this comprehensive overview, we will be exploring the various types of power plants and the vital role they play in supplying electricity to the grid. Join us as we delve into the inner workings of these plants and their source of power they harness. So in this presentation, we'll be discussing in details about the type of power plants which we had mentioned there. First, we will be discussing about the thermal power plant, then nuclear power plant, then renewable energy plant, and then combined heat power plant. We will be introducing 4 one by one and presenting the information we gathered into the slides. So first, we discussed thermal power plant, and in particular subcategory of thermal power plant, we had chosen fossil fuel power plants. So fossil fuels include the coal, natural gas plants, which are the most common types of the power plants, or we can say fossil fuels available in the nature. They burn fossil fuels to produce steam, which drives turbines to generate electricity. These plants emit carbon dioxide and other greenhouse gases, contributing to climate change. Despite their environmental impact, they remain a significant part of the global energy mix. Let's further discuss about these fossil fuel power plants mechanism in detail. So next slide, I have included the working mechanism of the fossil fuel power plant, and I will be explaining throughout the same. So in this, as we have discussed about the brief mechanism of this power plant, we can say that a fossil power plant, also known as a thermal power plant, generates electricity by burning fossil fuels such as coal, oil, or natural gas. The working mechanism involves several key components that work together to produce electricity, as mentioned here. So let me first explain one by one by annotating with the same. So here, first is air intake. First is this air intake part. So the air intake process begins with air being drawn into the power plant through an air intake. This air is needed for the combustion process. Further discussing about the combustion chamber. This part, the fuel such as coal or gas, is burned in the combustion chamber. The heat generated from the combustion process is used to convert water into steam. Further, this part or the boiler part is used as one of the components. The steam produced from the combustion process passes through a steam boiler. Process of steam boiler. A steam boiler has been also depicted here. So the working of the steam boiler is consists of tubes filled with water, which are heated by the high temperature gases from the combustion chamber. The heat transferred causes the water to boil and turn into the high pressure steam. Later on, the gas which has been produced is passed to the steam chamber, which is shown here in this part. Depicted in this part, steam turbine. Now steam turbine, the high pressure steam is directed into the steam turbine. The steam energy causes the turbine blades to spin rapidly. Later on, discussing about this part or the generator part. The spinning turbine is connected to the generator, which converts the mechanical energy from the turbine to the electrical energy. The energy consists of a coil of wire that rotates within a magnetic field, producing an electric current. Later on, this part or the transformer part is one of the most crucial part or the output part of this whole system. The electricity which is generated by the generator is transmitted at a low voltage. It is then sent to the transformer, which increases the voltage to the level suitable for the efficient transmission over long distances. Further discussing about the cooling system or the cooling water system. During the steam turbine process, the steam loses some of its energy and condenses back into the water. This water is then cooled down by the cooling water system, typically sourced from a nearby river or ocean. This cooling tower, the warm water from the cooling system is sent to the cooling tower, where it is sprayed or dripped down over a series of bubbles that facilitates the exchange of heat of the air, gases, and causes the water to cool down. So this is the cooling tower which we discussed recently. Later, the another part is this condensate pump, which is one of the crucial pump of the system. The cooled water known as the condensate is pumped back into the boiler to be converted into steam again. The condensate pump helps to maintain the continuous water cycle in the whole process of the system. Another part which we'll be discussing, which is the compressor and combustion system, also known as combine. So the combine system has been depicted here. So the brief idea about this component system is that in a gas turbine power plant, instead of the steam boiler, the compressor is used to compress the gas. The compressed air is mixed with the fuel in the combustion chamber, where it is ignited to produce high temperature gases. These gases then expand through the turbine, generating mechanical energy to drive the generator. Further, this is the gas turbine, which is one of the This is the gas turbine, which we'll be discussing now. In the combined cycle power plant, the gas turbine works as a conjunction with the steam turbine. The high temperature gases produced by the combustion process in the gas turbine are used to generate steam in waste heat recovery boiler. The steam then drives the steam turbine, further increasing the overall efficiency of the power. This is how we discussed about this whole mechanism of the fossil power plant in brief. These are the main components of involved in the working mechanism of a fossil power plant. The plant harnesses the energy released from the burning fossil fuels to produce the mechanical energy, which is then converted into electrical energy through the generator. The cooling system and the condensate pump ensures an efficient and the continuous operation of the power plant. Further, on this slide, we will be discussing about the different other types of the power plants, which are nuclear power plants. So now we will be extending our discussion regarding the power plants to another extent. Now we will be discussing about the nuclear power plants. Nuclear power plants harness the energy from the nuclear reactions to generate the electricity. They operate by splitting uranium and plutonium atoms in the process called nuclear fission. Unlike fossil fuels, nuclear plants produce electricity without emitting greenhouse gases. However, the safe handling and disposal of the nuclear waste remain key challenges in the operation of these plants. Let's further dive into the discussion depicting the working mechanism of this whole power plant in detail. So, as you can see, this is the working mechanism depicted in the particular chart. We have used a pressurized water reactor, a particular type of the nuclear power plant. There are various types of nuclear power plant, in which one of the type is this pressurized water reactor. So let's deep dive into the discussion regarding this. So first, I would like to explain that nuclear power plants is a complex system designed to generate electricity through nuclear reactions. It consists of several key components, each serving a specific purpose. So let's go through the working mechanism of a nuclear power plant along with the explanation of the mentioned parts. So first, I would like to explain about this part, which is the reactor part. Just a minute. Yes, so let's discuss about this reactor part. So the reactor is the heart of the nuclear power plant. It contains the core made up of nuclear fuel, usually enriched uranium or plutonium. Within the core, controlled nuclear fusions, reactions occur and releasing a tremendous amount of heat energy. So the main part of the power plant we can say is the reactor, which consists of the fuels which are required for this generation. Further, let's discuss about this nuclear core power. The nuclear core consists of fuel rods arranged in a specific patterns. These rods contain the nuclear fuel which undergoes fission when bombarded by the neutrons. The fission process releases heat and more neutrons which sustain the chain reaction. Further, one of the important part is this reactor cooling pump, reactor coolant. So the reactant coolant, usually water, circulates through the core to remove heat produced by the nuclear fission. It absorbs the heat and carries away to the next stage of the power plant. Further, we will be discussing about the steam generator. The hot reactor coolant transfers its heat to the secondary coolant loop, which is also water but kept under high pressure to prevent boiling. The transfer of heat takes place in the steam generator, where the heat from the reactor coolant converts the water in the secondary loop with the steam. Further, let's discuss about this high pressure turbine. The high pressure steam from the steam generator flows into the high pressure turbine as it passes through the turbine blades. The steam's high pressure and high temperature energy is converted into rotational mechanical energy, causing the turbine to spin. Further, let's discuss about the pressurizer part of the system. The pressurizer is a vessel that controls the pressure of the primary coolant loop. It ensures that the water remains in the liquid state even at high temperatures by maintaining a constant pressure. It prevents boiling in the reactant coolant loop. Further, let's discuss about this low pressure turbine. After passing through the high pressure turbine, the steam enters the low pressure turbine. The remaining energy in the steam is further utilized to generate more rotational mechanical energy. One of the other important part is this condenser. I would be like, yes, this part is one of the most crucial part of this nuclear power system. So the condenser steam exiting the low pressure turbine enters the condenser. The condenser is a large heat exchanger that cools the steam by transferring its heat into the cooling medium. Typically cold water from a nearby source such as cooling pond or a river. The cooling pond has been depicted here. Other part is traveling screen. Traveling screen is a device located in the screen house which prevents debris such as leaves, algae or fish from entering the cooling system. It ensures that the cooling water remains free from contaminants. Further, let's discuss about this feed pump and heaters. So the feed pump takes water from the condenser and increases its pressure, supplying it back to the steam generator. Before entering the steam generator, the water passes through the heater to increase its temperature using the excess heat from the condenser. Further, discharge pipe. After passing through the steam generator, the water now at the lower temperature is discharged back to the condenser through the discharge pipe. This process completes the primary coolant loop. And further, one of the most output part of this whole system is this generator, in which the whole energy which is produced is sent back to the power lines. These power lines are further connected by the households and other thing, or either say commercial systems, and these are the output or the utilization of this whole process which is discussed. So generators consist of a spinning turbines. They are connected, which converts mechanical energy to the electrical energy. The generator consists of a rotor and a stator, where rotational motion induces the electric current in the stator. In summary, if I want to say that nuclear power plant uses the heat energy which is generated by the nuclear fusion in the reactor core to produce steam. The steam drives turbine which are connected to the generator to generate electricity. The coolant system, pressurizer, steam generator, condenser and various pumps and proper operation of the utilizes, and they make sure the proper operation of this whole power plant keeps on going. So let's further discuss about the renewable energy power plants. Renewable energy power plants such as solar, wind and hydroelectric power plants are gaining prominence in the energy sector. These plants harness natural resources like sunlight, wind and flowing water to generate electricity. Renewable energy plants further offers clean and sustainable power generation options, reducing our reliance on fossil fuels and minimizing the environmental impact. So if one of the different types of renewable energy power plants are there, among them we have actually selected a one particular type, which is a wind based power plant. So in this whole topic of discussion, we'll be discussing about a wind based power plant system. So let's discuss about the system in detail. Now the wind energy power plant, also known as the wind farm, harnesses the kinetic energy of the wind and converts it into the electrical energy. Here is a step-by-step explanation of how a typical wind power plant works. So first of all, let me discuss about this part, which is the wind power. So wind power is the form of the renewable energy that is generated by the movement of air masses. When wind flows over the blades of the wind turbine, it creates a force that causes the rotors to rotate. This rotational motion is then converted to the electrical energy efficiently. Further, let's discuss about this rotator blades. The rotor consists of a hub and multiple blades attached to it. The blades are aerodynamically designed to efficiently capture the wind's energy. As the wind blows, it causes the blades to rotate. Further, this is the gearbox. The rotor is connected to the gearbox, which increases the rotational speed of the blades. The gearbox is necessary because the rotational speed of the blades is relatively low, while the generator requires high speeds to produce electricity efficiently. Further, this part is one of the crucial part of the system, which is the generator system. As depicted into the diagram of the system, this is the generator system. The gearbox is connected to the generator, which converts the mechanical energy from the rotor's rotation into the electrical energy. The generator typically uses the electromagnetic induction theory, where the rotating magnetic field induces an electric current in the stator windings, producing electricity. So you can say that it is one of the heart or the core part of this whole system, as it is responsible for converting this wind energy to usable household energy. So we can say this is one of the most crucial part of the whole system. Further, let's discuss of this part, which is the power grid and load. So this is the power grid and load. The electrical energy generated by the generator is transferred to the power grid. The power grid is a network of transmission lines, transformers and substations that distribute electricity to the consumers. The wind power plant is usually connected to the local regional power grid, enabling the electricity to be transmitted to homes, businesses and further industries. Let's further discuss about this yaw control. The wind turbine is mounted on the top tower, placed on a swivel mechanism called the yaw drive. The yaw control allows the turbine to align itself with the direction of the wind. An anemometer and a wind vane detect the wind direction, and the yaw drive adjusts the turbine's positions accordingly. This further ensures that the blades always face into the wind, optimizing the energy capture. So here we have smartly utilized our brains. The humans have smartly utilized the brains to convert such a system so that it always faces toward the wind direction, which can further efficiently produce the electricity. One other part is nacelle system. Nacelle is a housing structure located at the top of the wind turbine. It houses various components such as gearbox, generator, control systems, and it also contains some sensors, control mechanism which optimizes the turbine's performance, including wind speed, rotors, and other parameters. So the transformer is further like it works is same as the previous one. It converts the low voltage to the usable high voltage conversion, usable high voltage for household uses. So in brief, by capturing the kinetic energy of the wind and converting it into the electricity, wind and power plants produce a sustainable and clean power source. They contribute to the reducing greenhouse gas emissions and dependence on fossil fuels, making them an important part of the global transition to the renewable energy. Further, let's discuss about one of the fourth type of the power plant, which is combined heat and power plants. The CPH or CHP, or also known as cogeneration plants, simultaneously produce electricity and useful heat from the same energy source by capturing and utilizing the waste heat. CHP stands to achieve high overall energy efficiency compared to the traditional power plants, and these plants are find applications in industry, hospitals, and in district heating systems, providing an economical and efficient approach to the energy generation. So let's dive deep into the working mechanism of this whole system. In like here we have discussed one of the crucial and one of the most widely used fossil fuel, which is coal. Here coal is used to produce heat, and that heat is further used to produce electricity. So let's discuss about this in detail. So yes, the coal-field power plant is a type of a thermal power plant that generates electricity by burning coal. The working mechanism of a coal-field power plants include several components working together. Here is an overview of each part. The first we can say is, let's discuss about this part, which is the transformer part. So the transformers are used to increase and decrease the voltage of electric power. The coal-field power plant, large transformers are used. They are large step-up transformers are used to generate electricity voltage for efficient transmission over long distances to the power lines. This part is the furnace. The working of the furnace is that where it is the place where coal combustion takes place. Coal is burned in the combustion chamber, often referred to as a furnace, to release the heat energy. The heat energy generated from burning coal is used to produce steam, as you can see here. Here the one of the component which is kept is called a boiler. The furnace heat is transferred to the water in the boiler, converting it into the high steam pressure. The boiler is closed vessel where the water is heated to the boiling point, used in heat energy from the boiling coal. The steam produces it is produced at the high temperature and high pressure, which is further used to move the turbine. We'll further discuss it ahead. This is the generator. The working of the generator is that it is a high pressure steam directed to the turbine which drives the generator. The generator consists of a rotor and a stator. As the steam flows through the turbine blades, it causes the rotor to spin. The rotating rotor induces the electric current in the stator windings, thereby generating the electricity. Further, this is the turbine part. The steam from the boiler expands in the turbine, causing the turbine blades to rotate. The turbine converts the kinetic energy of the steam into the mechanical energy, which in turn drives the generator to produce electricity. The turbine and the generator are usually coupled on the same shaft. This part, at the particular this part, the condenser part is also included. So it is not included in the diagram, but one of the another part is condenser. The working of the condenser is that after passing through the turbine, the steam enters the condenser. The condenser is a heat exchanger that cools down the steam, causing it to condense into the water. The condensed water is then pumped back to the boiler to be heated again and converted back to the steam. This part is the power lines, or the the output channel of this whole system. The electricity generated by the generator is sent through power lines, also known as transmission lines, to deliver the electricity to the consumers. The high voltage power lines are used to transmit the electricity efficiently over the long distances. Substations are along the power lines, step down the voltage before distributing to the electricity to the homes, businesses, and further industry. In summary, if we discuss, the coal-filled power plant burns coal in the furnace to generate heat. The heat is used to produce steam in the boiler. The high pressured steam drives the turbine back into the turn which in turn drives the generator to produce electricity. The steam is then condensed back into the water in the condenser, and electricity is transmitted to the power lines for the distribution. So in this whole process, we can say that this fossil fuel is like converted to the electricity, which can be used in like households. So in the whole process, the working of this power plant has been discussed through this method. This is the input where the coal is like mined by the humans and for the supply to the system. So if I just brief out the whole system of the presentation, is that if I conclude that power generating plants play a crucial role in our meetings our ever increasing electricity demand, while fossil fuel plants remain dominant. Transition towards renewable energy sources is gaining the momentum. It is essential that we continue to explore and invest in sustainable alternatives to reduce our carbon footprint and mitigate climate change. Together, we can shape the future powered by the clean and efficient energy. So, I will be thanking the professor to pay time to my watching my presentation. I hope I was able to meet the expectations of the faculty. Thank you very much.